Hello everybody, welcome back. This is lesson 2 in unit 4, and today we're going to talk about dimensional analysis and finally talk about what the mole is. Okay, so in the last video we talked about significant figures. Yes, it was a very long and boring video. I am aware. Hopefully this one will make up for some of the boringness. Okay, so like we said, we're going to talk about dimensional analysis. And so just a heads up, this whole unit and a lot of stuff moving forward is a lot of calculations. So just kind of keep that in mind, especially this unit though. This unit and the next unit has a lot of math. Okay, so what is dimensional analysis? It's a useful tool to convert between units. And so basically it uses things called conversion factors made from any two terms that describe the same or equivalent amount. So what that means is that 60 seconds and 1 minute, they both say the same thing. That would be an equivalent amount or a conversion factor. The fact that 60 minutes are in 1 hour, that's a conversion factor. 24 hours in 1 day, and 365.25 days in a year. Yes, it is 0.25 days. If you took earth science, that's something your earth science teacher kind of talked about. That's also why we have a leap year every 4 years. So, moving forward, if I wanted to answer this question, how many days will it take to reread the Harry Potter series if I read non-stop? And so this is a question we can use dimensional analysis for, but we're going to need to know some basics. So there are 4,224 pages in all 7 books. Thank you, Google, for that fact. Let's say I read 300 words per minute, and there are about 367 words per page. Now, I'm just going to run through this quickly to kind of show you how dimensional analysis works and kind of step back and work through simpler examples. So, there are 4,224 pages. Now, I can read on each page, there are 367 words, 1 page. Okay. And in 1 minute, I can read 300 words. And there are, in 1 hour, there are 60 minutes. And then but I want to figure out how many days. So in 1 day, I know there are 24 hours. So my math is all set up. So what this shows, I'm just stacking all these conversion factors and stringing them along, and that's what dimensional analysis is. Now I set it up a specific way, and hopefully you can kind of pick up on it. Now, the way dimensional analysis works, all of your units should cancel out except for what you're looking for. So the question is asking for days. So if I set this up correctly, all the units should cancel out except for the word day. And so pages cancel out because if you have one on top and one on bottom, they cancel out. Words cancel out. Minutes cancel out. Hours cancel out. And I'm left the only unit, day. So now I know my units are set up. I set up my conversion factors correctly. And so moving forward, you're left with 4,224 times 367 times 1 times 1 times 1 over. So to get here, all I did was take these top numbers, multiply them together. I'm going to divide that by 1 times 1 times 300 times 60 times 24. So if we were to plug this into a calculator, which I did beforehand, I get 155.0208 divided by 432,000. And when I do that on a calculator, I get 3.59. And our unit, remember, the only thing we didn't cancel is days. So it would take me 3.59 days if I read continuously at 300 words per minute to read all 7 Harry Potter books? Okay. Now that was a pretty tough question. And we're gonna kind of take a step back and work on simpler ones. But let's kind of look at this again. So basically what I did, I looked at what I was starting with and I put it over 1. And then I want to see where I wanted to go. And then I had to figure out all these useful conversion factors. So that's why I told you, how many words per page there were, how many words I could read in a minute and stuff like that. And then kind of move step by step and string along these different conversion factors until everything cancels out except for what you're looking for. So let's try this one other long question, and we'll kind of take a step back and do it simpler. So how many seconds are in 3.5 years? I know this is a question that you've definitely pondered long and hard about. So look at what so let's kind of get into this. Step 1 is to look at where you're starting and to put it over 1. So we're starting with 3.5 years. So let's write 3.5 years and put it over 1. Okay. Look to see where you want to go. So we want to end up, let me get a different color here. We want to end up in seconds. Now, I can't go directly from years to seconds because I don't know how many seconds are in a year. So I'm going to have to figure out some useful conversion factors. And then, move step by step until everything cancels out. So if we want years to cancel out, we're going to want to put it on the bottom. Now, what's smaller than a year that we can kind of eventually work our way to seconds? And I'm going to say days. So in 1 year, there are 365.25 days. So here right now, we know years cancel out. So now we're in days. That's our unit. But again, we want to go to seconds, and so we're not done yet. So days have to cancel. We're going to put that on the bottom. And so what's smaller than a day that can help us get to seconds? And hopefully you're thinking hours. So 24 hours in 1 day. Here, days cancel, and now our unit we're in is hours. Again, we're not there yet. Almost. Not yet. Okay. So now we want to get rid of hours. So we put hours on the bottom. And what's smaller than an hour that helps us get to minutes? Helps us get to seconds rather. You should have thought minutes. So again, there is 60 minutes in 1 hour. And now hours have canceled out and we are in minutes. Again, not done yet. We want to get rid of minutes. That goes on the bottom. And then we can finally go from minutes to seconds. There are 60 seconds in 1 minute. Minutes cancel. And so we're left with just our unit of seconds. So now we know we've set it up correctly. And so what that leaves us with is 3.5 times 365.25 times 24 times 60 times 60 divided by 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, like that. And so when you do this, you get 10962,000 seconds. And so that's how many seconds are in 3.5 years. Now, if you were to convert use different conversion factors, so let's say instead of using 365.25 days a year, what if you did it 52 weeks in a year? And then 7 days in a week, and then break it down that way. So I'm curious to see how different that would be. So if you want to use 52 weeks per year as a conversion factor, break it down that way, and then in the last question, let me know how different your answer is using that factor. Okay, so that's dimensional analysis, but we're going to kind of focus it back on much, much simpler examples. So if you were a little bit confused, that's okay. If you like these long strings, fantastic. But let's kind of think about this in much smaller senses. So here are a dozen cupcakes. If I said a dozen cupcakes, you know that means 12. And so, generally speaking, you don't order one cupcake. You order them generally in batches of 12. It's a convenient number. If you're buying paper, you don't buy paper, one sheet of paper at a time. You buy it in reams of paper. So if Jim and Dwight were selling you paper, they're not going to sell you it page by page. That would be silly. They sell you it by reams or even boxes of paper because that's what's convenient for that specific type of thing. Okay, so for today, I'm going to make up a unit. And I'm going to call my unit an owl. We're sticking with the Harry Potter theme, so let's use owl. Here is an owl. Bonus points that don't exist if you know what Harry's owl's name is, and what owl actually stands for in that series. Anyway, owl is a made-up unit, and I'm going to say it means we have 4 things. So just like a dozen means you have 12 things. So if you had a dozen oranges, you'd have 12 oranges. If you have a dozen pencils, you have 12 pencils. So with the made-up unit, if I have an owl of oranges, I have 4 oranges. Because I'm telling you, an owl is 4 things. If I have an owl of molecules of water, it means I have 4 molecules of water. If I have an owl of atoms of iron, how many atoms of iron do I have? You should say 4. So one owl is 4 things. So let's use dimensional analysis to convert Twizzler owls to Twizzlers. Now you might be thinking, well, duh, I can do this in my head really quickly. I don't need dimensional analysis. And yes, you totally might be right. But numbers are going to get kind of ugly. So if we can do it with simple numbers and it makes a lot of sense, when the numbers get ugly and the word of the unit gets kind of ugly, it's still the same thing. So if we think back, we want to figure out what we're starting with, which is 2 owls, and we put it over 1. So it's always your first step. Find what you're starting with, put it over 1. Okay. And now we want owls to cancel out, and we want to figure out how many Twizzlers we have. So remember, 1 owl is 4 things. So in 1 owl, we have 4 Twizzlers. So owls cancel out. You're left with 2 times 4 divided by 1 times 1, which gives you 8 Twizzlers. Now, yes, that is super simple. You could have done it in your head. But again, when numbers get uglier, you'll be happy that you know how to do this. FYI, Twizzlers are my favorite candy. Okay, heading with another one of my favorite candies. How many Sour Patch watermelons are in 2.3 owls? So, still on the simple side, but harder to do in your head. So if we're starting with 23.2 owls, you put that over 1. You want owls to go to cancel that, so you put it on the bottom. And we are looking for Sour Patch watermelons, so Sour Patch watermelons. And because of this made up unit, we know that 1 owl is 4 Sour Patch watermelons. So our owls cancel, leaving us with Sour Patch watermelons, and we get 23.2 times 4, which gives us 92.8 Sour Patch watermelons. And that is it. So for most of the conversions that you'll be working with in this unit, there'll be, I would call this a one-step dimension analysis question. You may have 2 steps, but it stops at 2 steps for this unit. So the seconds in the year, or the how long it takes to read Harry Potter, we're never going to, in this class, string them along that long. But if you want questions like that, just for fun, let me know. Okay. How many gummy bears are in 0.75 owls? So this is what we're starting with. You put what you're starting with over 1. Again, you want owls to cancel out, so you got to put it on the bottom. And we're looking for gummy bears. I'm going to abbreviate that GB. And we know that there are 4 gummy bears in 1 owl. Again, my made-up unit, 1 owl is 4 things. Okay, so here, owls cancel out. Remember, they cancel out if you have top and bottom. And then you're left with 0.75 times 4, which gives you 3 gummy bears. Exciting. Now, we're going to flip it. So now, what we're doing, I gave you owls, and we calculated things. Now let's do number of things and calculate owls. So here, my cookie dealer at my cookie dealer on Instagram sells amazing cookies. They literally are half-pound cookies. So here is a red velvet cookie with a black and white cookie baked inside of it. If you order 20 of them, how many owls of cookies is that? So we're starting with what we know. We're starting with 20 cookies. 20 cookies. That's your given. Put it over 1. And so now we want cookies to go away. So cookies goes on the bottom. We are looking for owls. Owls goes on top. Again, we know 1 owl is 4 cookies. So cookies cancel out. We're left with 20 times 1 over 1 times 4, which is 20 over 4, which is 5 owls. Again, you might be able to do this in your head. Fantastic. But again, once numbers get more scary, this helps. If you check out my cookie dealer and order cookies, let me know what you think of them. Okay, so it's the holiday season. Candy canes are big now. If someone gives you 1 candy cane, how many owls of candy canes did they give you? Well, we are starting with 1 candy cane. And so you put that 1, whatever you're starting with, over 1. And we want candy canes to cancel, so they go on the bottom. And we're going to owls. Again, in 1 owl, we know that there are 4 things. In this case, these things are candy canes. So the unit candy cane cancels out. You're left with 1 times 1 divided by 1 times 4, which is 1 over 4, which is 0.25 owls. So if someone gave you 1 candy cane, they gave you 1/4 of an owl. Yay! Okay. So, last question of this. How many owls is 432 Ferrero Rocher chocolates? FYI, my cookie dealer put these inside of cookie as well. Didn't try that one though. Okay, so we're starting with 432 Ferrero Rocher chocolates. I'm going to abbreviate that FR. That is your given. You put your given over 1. Now you want FR to cancel, so it should go on the bottom. We're looking for owls, so that goes on the top. In 1 owl, there are 4 Ferrero Rocher chocolate balls. And so that cancels out, so we know we set it up correctly. We're left with 432 divided by 4, which gives us 108 owls. Just like that. Okay. So, since we're talking about owls, yes, it has a Harry Potter theme, but it's an animal named after it. It's a unit named after an animal. So, this whole unit is talking about moles. Well, what is a mole? And so, if we talked about, when we talk about, ordering cupcakes or reams of paper, you'd have that number because it's convenient for what you're using. And obviously, if we calculated molecules by owls in groups of 4, that wouldn't work because you'd have so many of them. And so, scientists had to create a unit that makes it easier to deal with a big number of molecules. And so this dude right there, Amadeus Avogadro, he was counting water molecules because he's bored. There's no TV, there's no Netflix. And he's like, oh, I can't use dozen, it's too many. I'm going to create a unit, and I'm going to name my unit Mole. He had a pet mole as a pet. So he's like, oh, my favorite pet is a mole. I'm going to name my unit after my favorite pet. And so he said, so just like one, different color, just like 1 dozen is 12 things, Avogadro said 1 mole is 602,200,000,000,000,000,000,000,000 things. And so that's what he said. So he said 1 mole is 6.022 times 10 to the 23 things. So if you had that many things, you'd have 1 mole of that thing. And so that is what a mole is. A mole is that number of things. So it's like 1 dozen is 12 things. 1 mole is 6.022 times 10 to the 23 things. And so, fun fact, October, so 10, 23rd is Mole Day that people like to celebrate. So there's that. So in the next video, we'll talk about using this number in our conversions. So this number is a lot scarier than 4 things in 1 owl, but it works the same way. So on that note, that is it. Next video, we'll talk about how to convert between moles and particles. So just like what we did today, but with that big scary number. And if you were to calculate the number of seconds in a year using 52 weeks, let me know how different the numbers are. If you have any questions, leave them behind. Have a wonderful day. Bye.